Pre-Module 4, solving three-step equations with variables on both sides of the equal sign. So when we first look at this problem, we see there's a y here and a y here. We haven't really seen that before, maybe last year, but so in order to solve this problem, we need to make it so there's only one place that we see a y in the problem. So to eliminate this y, we can add 4y, because if we have negative 4y plus 4y, it adds up to 0y, which means we don't have any. Over here, we now have 11y minus 3 equals 30. Two-step problem, simple. Add the 3 because you have to get rid of what's added or subtracted first, and then divide by 11 because you have to get rid of what's multiplied or divided last. So our answer for y would be 3. Now I'm going to go back to this problem, and I'm going to show you that you can also solve this by getting rid of this y first. So if I want to get rid of the 7y first, because it's positive, I need to subtract 7y on both sides. That will leave me with negative 3 equals 30 minus 11y. Now I have something multiplied, something added. I need to get rid of what's added. Okay, because this is a positive 30, I need to take negative 30 here. And then I need to get rid of the negative 11 that's multiplied, and I'll do that by dividing. So y equals 2 negatives make positive 3. Now I can also check this answer. So if I take my original equation and I substitute in a 3, I should be able to check this. 21 take away 3, 30 take away 12. Well, 21 take away 3 is 18, 30 take away 12, 18. It is the correct answer. Okay, so 3 is right. Now, here's the second problem. Here's the second problem I want to show you. Something unique is going to happen in this question as well. So if you have negative x equals x minus 20, a lot of people want to start by getting rid of this x. So if we want to get rid of this x, that's actually a negative 1x. So we're going to add 1x. This is also a 1 over here. Negative 1x plus 1x cancels. And what do we have on the left side of the equal sign now? Nothing. 0. We have to put a number in there. 1x plus 1x is 2x. We bring down the minus 20, and now we have a two-step equation to solve. Add the 20, because we have to get rid of the thing that's added or subtracted first, and then divide by the 2, because we have to get rid of what's multiplied or divided by the x second. And our answer here is 10. Now I'm going to show you on this problem, the same as I showed you on the above problem, that you can work this either way. So if you didn't want to get rid of this one first, you could get rid of this 1x first. It's a positive 1x, which means we have to subtract it to get it to cancel. Negative 1 is negative 2x. Divide by negative 2, because the only thing going on here is multiplication, and I get positive 10. Two negatives cancel, make positive 10 here. Same answer. We can also check this the same as we did previously. Negative x equals x minus 20. So x minus 20 turns out to be negative 10 equals negative 10. So it does check.